This video instruction is for the circuit builder exercise called Resistors in Parallel. The first circuit it has you build is a 6-volt battery, a switch, and then 2 resistors in parallel. It tells you that the total current is 2 amps with your 6-volt battery, and you have to determine what value to put in for the resistors. And when you click on the resistor, it'll pop up a little window down here in the lower right, and you can change this resistance value. In order to figure what the total resistance should be, you would take the volts divided by amps, and that would tell you that the total resistance of the circuit needs to be 3 ohms. And if you remember from the lesson on parallel resistors, if you use the formula product over the sum, you can determine the total resistance. And I did that here because it's fairly simple to remember that if you have 2 6-ohm resistors and you put them in parallel, it'll be 3 ohm. And that works with, if it was 2 100 ohms, it would be 50. It just divides it in half. So product over the sum, total resistance of 3 ohms, that will give us our 2 amps. So for each resistor, we will need to enter the value here of 6 ohms. Another way to figure this same circuit is to divide the 2 circuits, the 2 paths for current to flow. And we know that we have 2 circuits for current to flow. We want a total of 2 amps. So we will actually end up with 1 amp per circuit. If we take our 6 volts divided by the 1 amp of current for each circuit, that would tell us that each resistor needs to be 6 ohms. And again, you would put in the value here of 6 ohms. The second circuit that you need to do in resistors in parallel is to build a circuit that has 3 resistors in parallel with 18 volts. And the way to get 18 volts is to actually stack 3 6-volt batteries. So you get 6 volts, 6 volts, 6 volts, a total of 18 volts. We've got our 3 resistors in parallel. It tells us that the total current is 1.26 amps. So we can divide the 18 volts by 1.26 amps, and we know that the total circuit resistance has to be 14.2857 ohms. Now, the formula for resistances in parallel is the resistance total, which we just found here, is going to be the inverse of the inverse, and it's really difficult math. But basically, you come down to you need the inverse of 14.2857. The inverse of 14.2857 is 0.07. If we divide that by 3, assuming that each one of these resistors is going to be the equal value, we would come up with 0.02333. And the inverse of 0.02333 is going to be 42.86 when rounded to the nearest hundredth. A simpler way to find the resistance of the 3 resistors in parallel might be, if you look at, again, 18 volts, 1.26 amps, we know that each circuit we're trying to put in the same resistance so that it's divided evenly between the 3. If we take 1.26 divided by 3, it would tell us that we need 0.42 amps per circuit. And if we divide the 18 volts by the amperage that we want per circuit of 0.42, that would again give us our 42.86 ohms, and you would need to enter 42.86 ohms for each one of the 3 resistors in that circuit. If you have already tried the resistors in parallel exercise and you made the mistake and had not gotten the resistances right 3 times in a row, it will tell you what the solution is that they came up with. And I'm not sure how they come up with this solution, but it recommends that you use a 40 ohm, 40 ohm, and 50 ohm. Now, resistors are only available in certain resistance values, and 40, 40, and 50, these still are not common resistances, not something that you would go find at an electronics store. But here's the math involved in the selection of 40, 40, 50, which is uh, what the exercise recommends. If you had 18 volts at 40 ohms, that would be 0.45 amps. And your second resistor, again, 40 ohms, 0.45 amps. And then your third resistor, 50 ohms, would be 0.36 when you do the math. That would total 1.26 amps. So you would have to put in a value of 40 amps or 40 ohms for the first resistor, 40 ohms for the second resistor, and 50 ohms for the third resistor. And that would also work to solve the exercise.